Mills, Mr. Mills, um, and I am completing ITL 528 week 4 by teaching a lesson that I drew up week 3 of understanding random sampling. And this is a valuable lesson to be taught in seventh grade mathematics. It's actually a late seventh grade mathematics that I've talked to a few current seventh grade math teachers saying they don't even get to this. They don't even get to this unit throughout the entirety of the school year just because they run slow on time or whatever, because it is the last or is the end of the school year unit. But I think it's important because you do evolve on statistics and probability as you go through your educational journey. When I was in high school, I took AP statistics, but I had um, no prior knowledge of any type of statistics and probability going into that. I remember I was an econ major when I was in school myself, and I took as a prerequisite, I took statistics as well, and I know many business majors that took it. I knew finance majors that took it. So I think it's very valuable and applicable to use or to be learned earlier in life, like in seventh grade, for example. So I chose this because I think it is a cool. It's fun. It's statistics is fun. It's valuable to future education and everything. But having said that, I tried to coordinate with my father, who's a teacher in Palm Springs Unified School District, that we were going to. He was going to try to get me like 4 or 5 students so I could teach this lesson too. But it's just the timing of everything, COVID, my work schedule, his work schedule. He has extra collective bargaining after school, so he can't really do it after school with the students. So I just have to do this as I go and make the best of it and teach it to uh, teach it to nobody, but hopefully heighten my ability to deliver a lesson, which is the ultimate goal of this. So what I'm going to do is I'm going to start screen sharing for the PowerPoint presentation that I've prepared. Here we go. Sorry, I'm on the wrong slide right here. We'll go back. And so I'm just going to teach this as if I was teaching to a group of seventh grade students. So today we're going to be looking at understanding random sampling and drawing inferences about a population. And random sampling is valuable because it helps you make predictions, and it's very applicable to like real world scenarios. It can be used to gather data on very relevant topics in the world right now, such as the election that's going to be happening in early November. It's a valuable thing to have. And so what random sampling is when you conduct a survey, sometimes you can't ask every person exactly what they prefer. So you only survey a sample or portion of the population to gather data which you can actually work with. An example of this would be if you wanted to do preferences of school lunch in a school district, for example. Say there's 60,000 kids in the school district. There's no way you're going to ask 60,000 kids what they prefer for hot lunch. Some of them may even bring their own lunch. So what you do is you go to a couple schools cafeteria and then you use random samples by going into a cafeteria and seeing all the people who got uh, hot lunch, and then you walk by and you ask every 20th person what they prefer. Like say it's like hamburgers to hot dogs or whatever. Do something simple like that, and then you gather a small amount of data to make an assumption or an inference of a larger population of data, which is very effective in real world scenarios as well. For a sample to be random, it must be fair. For example, you want to know if a students in a school prefer regular milk or chocolate milk. A random sample of the population would be to choose every 20th person in the lunchroom and asking them which of the two milks they prefer. However, if you asked every girl in the lunch line, it might not give you a good sample because you exclude a big part of the population. You're excluding all the boys and all the students who brought their lunch from home. So that would be neither random nor fair. So what I want to do next is I want to talk to my students and ask them if these samples are random. So for example, one, a survey is taken of favorite sports in eighth grade, but only girls are surveyed. Is it a random sample? Well, no, because you're excluding half the population in boys, and it's asking a survey is taken of favorite sports in 8th grade, but you're only surveying girls. So that's not a random sample. It's neither random nor fair. Example 2, a survey is taken of how students get home from school, and you survey the students in a bus line. Is this a random sample? No, it's also not a random sample because you're excluding all the kids that ride their bikes to school. You're excluding all the kids that get driven by their parents, carpool, walk home. There's a bunch of other ways to get home other than using the bus line, and you're only asking the students in the bus line. So they're obviously going to say, hey, yeah, I take the bus to get home. So you're getting a very unfair sample there. Third, you want to know if students bring their home lunch or get school lunch. You get a printout of all the students in a school and survey every 25th person. Is this a random sample? Well, yeah, because you're getting a printout of every student in the school, so you're not excluding anybody, and you're asking or you're surveying the 25th person or every 25th person that you see. So you're doing it very randomly as you go along, and you're not excluding anybody. So the sample is fair, valid, and random. And just, I put this as a side note at the bottom. Remember, for a sample to be random, every person surveyed must have an equal chance of being selected. And that's what example 3 provides for a printout sheet of every student in the school. So next, we're going to work on some problems of random sampling. How can we make population inferences from a random sample? So I've set up a problem on the right, and then I've asked the question is actually in the right, but I provided the steps on how to solve it. And you could do this either through a proportion or a percentile, but I'm going to start with a proportion and a part-whole relationship just because I find it easier. I think percentiles, I don't know, they're both equally easy, but I'll teach them both and just see what students prefer. So the question on the right asks, an internet company randomly selected 50 of its customers and asked them how many hours per week they use the internet. Of those surveyed, 28 use the internet more than 15 hours per week. Based on the data, if the company has 800 subscribers, how many use more than 15 hours per week? So how we're going to do this is we're going to set up a part-whole proportion. And this is where it would be very valuable to be teaching in front of a class with a whiteboard, but current times don't allow for that. So what I'm going to do is I'm going to take a notebook, and then I'm going to go through it step by step, and hopefully students will follow along with this. So we're going to set up a proportion, which was what we learned in 6th and 7th grade. And it's just, you set two fractions equal to each other. And we already know what we're looking for is how many users use more than 15 hours per week out of 800. So we're going to set that proportion up on the right. We're going to go x over 800. X in the numerator, 800 in the denominator, because we're trying to find out how many of 800 use the internet more than 15 hours per week. On the left-hand side, we're going to do the 50 surveyed, which is your denominator, and then you're going to put 28 people chose that, or surveyed that they did use the internet more than 15 hours per week. And then so now you got a proportion, which I'll show right here, which is 28 over 50 equals x over 800. And then you're just going to do simple cross multiplication, stuff you've been learning early 6th grade. So we're going to do 28 times 800, which we end up getting 22,400. And then we're going to do 50 times x, which you get 50x. And then to see how many people use the internet more than 15 hours per week, we're going to divide each side by 50 to solve for x. So we divide both sides by 50, and you get 448. So your proportion and your answer should look like that. So we can make the inference that 448 out of 800 subscribers to the internet company use the internet more than 15 hours per week. And that's just the basic generalization that we can make from given data, which is really cool because it is very applicable to many other scenarios in life. And so now we're going to do some extra practice with proportions. I'm going to flip the page right here so we can get some more work. So below is data collected from a random sample of 40 people, patrons at the public library. If the public library has 300 people, then see if the questions on the left are true or false. So we can look at the first question and say 75 people can be expected to choose a science fiction book, true or false. Well, we know that 40 people were surveyed, so we know that's our denominator on the left-hand side. And then we look at the at the box that's given, and we see that 10 people chose science fiction. And then we go on the left, and there are 300 people or patrons within the library. And then we're going to put X because that's the number we're looking for. And then we're going to do the same simple cross multiplication as we did before. We're going to do 3,000 because 300 times 10 equals 40x. Then we're going to divide both sides by 40. And then we're going to get x equals 75. So the question was asking us, 75 people can be expected to choose a science fiction book, true or false? Well, that's true, because when you do the set up the whole part-whole proportion, you get x equals 75. So that's true. Next, we're going to go on to two. Nonfiction and science fiction represent over half the selections, true or false? Well, this one's a bit simpler because all you have to do is find if it's over 50%, and we know 40 people were surveyed, so 20 over 40 would equal half. So if it's over 20, then yes, it's true. So we're going to look library patrons, nonfiction 12 plus 10, because 10 chose science fiction, so that would equal 22. You put the proportion 22 over 40, or the fraction 22 over 40, you would get over 50%, so that is true. For the last one, 136 total patrons can be expected to choose a nonfiction book, true or false? Well, this one is just similar to number one. We're just going to set this up in the same way, but we're going to do it with nonfiction instead of sci-fi. So we're going to put 12 over 40. 12 out of the 40 people chose science fiction, 12 out of the 40 surveyed. And we're going to put over 300, or we're going to put x over 300 because there were 300 people surveyed. And then we're going to solve for some simple cross multiplication as we did before. So 40x equals 300 times 12, which I believe is 1200. And then you're going to divide by 40 on both sides to solve for x. And then you're going to get x equals, wait, I did that first multiplication wrong. I'm sorry. Apologies for 1 second. 12 times 300, 3,600. Sorry, sometimes I go a little fast. 3,600. So it would be 3,600 divided by 40, which you would end up x equals 90, I believe. So 90 people can be expected to choose a nonfiction book, not 136. So that answer would be false. And those are some basic general questions that will get more intricate as we go along throughout the unit for sure. Okay, and this is what I was talking about earlier when you solve for percentages. It's the same data on the right. And we're just going to go through these using percentages that we learned early 6th grade as well. So exactly 42% of the library patrons choose mystery, true or false? Well, we'll set it up in a fraction just like we did before. We're going to go 18 chose mystery out of 40. And if you do simple division, 18 divided by 40, I believe you get 45%. So it says exactly 42% of the library patrons chose a mystery. That is false because 45% of the library patrons that were surveyed chose mystery. So we move on to number 2. Over 25% of the library patrons chose a science fiction book, true or false? Well, we can set that up as a simple fraction. 10 chose science fiction, over 40 surveyed, which is 1/4. 10 over 40, which is equal to 25%. So that is false because it says over 25% of the library patrons chose a science fiction book, and exactly 25% chose. Simple. So what percent of patrons chose a nonfiction book? So just a simple fraction and percentile. 12 over 40. 12 people chose nonfiction over the 40 people surveyed. So 12 divided by 40, I believe, is 30%, or it'd be 0.3 in divisional terms. And then you move the decimal over 2 places. Remember, we're working with percent, so it's not 3%, it's 30%. And then you get 30%. So that's a fill in the blank mainly answer. And